There's my Twitter handle there if you want to tweet abuse at me. This is the tale of an intermediate coder trying to implement a asynchronous programming in Ruby. And the title of this talk is "We Are Not a Threading Guy." So Ruby was my first language, and most of what we experience in Ruby happens synchronously. One thing starts, then it finishes, another thing starts, then it finishes. It's all about synchronicity. Then I started doing some work in other languages, like JavaScript, where it felt like things were happening all at the same time, even if that wasn't actually the case. So I learned some cool tricks like set timeouts to deal with that. And also realized there were some benefits to asynchronous programming because, for one thing, you can get tasks to finish quicker. So yeah, following is my story about trying to do this in Ruby. And the task that I was undertaking is one of the scariest things known to programming, which is CSV data import. So basically, we had an existing app that we had a rig task written. The programmer would go in and import all this data from the CSV. And I wanted to move that out into the content management system so that the user could do it, but we didn't have to be bothered with it. But in order for that to work, it needed to happen a lot quicker because no one's going to sit around for 30 minutes while this thing imports. So I thought I might get some speed benefits using multi-threading. But like all horror movies, the protagonist has to make bad decisions at the start, and mine was to do no research and just jump right into it. And had I done a little research, I would have come across things like this, which is where I got the name of my presentation from. And this is basically highlighting that Yokihiro Matsumoto, or however you say that, is the dude who wrote Ruby, and he's not really into threads, so that should have been a warning signal. Another fact is that Ruby has a mutable state, which can be a problem when multiple threads are trying to change data. So that turned out to be tricky, and I'll talk about some ways that Ruby tries to get around that. Anyway, if I'd done some research, life would have been a lot easier, but I didn't. And instead of using vanilla Ruby threads, I started with Celluloid. So Celluloid is an after-based concurrent object framework for Ruby. This talk's not about Celluloid, but it relies on it pretty heavily. But I feel like the lessons I learned even using Celluloid are applicable for vanilla threading as well if you want to, if you're brave enough to do that. Why did I choose Celluloid? Because Dangerous Dave said to try it, and he knows his shit, so that's as good a reason as any. It gives you lots of stuff that would take a long time to write, like handling what they call actors dying, which are threads behind the scene. Does things like notifications and callbacks. It also has heaps of cool features that I didn't really use and won't be talking about, like managers and supervisors and conditions, and these are all things that give you a lot of cool stuff, so you guys should check it out if you're interested. And people who actually understand multi-threading wrote it, and I definitely was not one of those people when I started, and probably am still not. So, before I get into the talk, just a quick overview. I know there's like a mixture of people here, so for people who don't really know about threading, this is the Ruby programming language, wrong, older version of Ruby, but it just talks about threads and concurrency and says traditional programs have a single thread of execution. The statements or instructions that comprise the program are executed sequentially until the program terminates. A multi-threaded program has more than one thread of execution. Within each thread, the statements are executed sequentially, but the threads themselves may be executed in parallel. So yeah, that's kind of what that's all about. So on to some code. This is basically just a class, and you include Celluloid, obviously, and then you get the things that Celluloid gives you. And if you look down at the bottom method there, you can see on the actor instance I call Async, which is a Celluloid method, and processes that with a thread. In the top method, you see self.terminate. With celluloid in this way, it doesn't handle garbage collection, so you have to actually terminate the threads yourself or die. Anyway, so I ran this and benchmarked it against synchronous coding, and it was not faster, which was not good. This was just my first experiment. I also didn't like the idea of having to instantiate a new actor inside of an iteration over an indefinitely long CSV, because you could have 10,000 of them. And I also didn't want to have a garbage collection. So I did some more research in celluloid and found that you can create pools of actors. You can see in the bottom method there, I define a pool of actors which has 5 in it, and it handles garbage collection for you and everything. And when I ran this, it was 50 times faster than synchronous, which is way too fast. And for people who are more senior, they probably know I was making a super new mistake here. Does anyone know what it is? Hands? No? I'm sure you guys do when I tell you. All the actors were actually dying. What was happening is the main thread would load up the actors with work, and then it would be like, I'm done, and it would terminate, and all the actors would get terminated as well. So they weren't actually finishing anything that they were doing. So yeah, that was no good. And on to the next brutal killing. With vanilla threads, you can gather all your threads together and call join on them, and join all the threads together, and then they wait for each other to finish. With celluloid, you can use futures. So if you look at the bottom method there, pool.future is the celluloid method. You pass in the method you want to call, and then you have to map over the features and call value on them, and that's the thing that gets them to wait. So with this, it would wait. The main thread would wait until all these things had finished. And when I ran this and benchmarked it, it was slower than synchronous. So that was not what I was expecting. It was bloody slow.
Excuse me, what type of a machine were you running it on?
Well, I'll get to that actually, yeah. So the machine does make a difference, and there's lots of things about threading that make a difference that shat me. But that was not actually the problem here. The problem here was actually this line. If you look back to this method, I've got this arbitrary thing that just iterates over a number and doesn't do really anything important. The examples I looked at online were actually calling sleep, and that turned out to be important. I thought this was like at least more simulating like work, whereas sleep was just like, you're not going to write a program that sleeps. But it turns out that with the Maths Ruby interpreter, which is the standard implementation of Ruby, it's got this thing called the global interpreter lock. And awesomely, that thing stops more than one thread from executing at a time for CPU-bound tasks, which this is 100% CPU-bound. So I had all these threads working, but only one of them could ever run at one time. And just some more on the GIL. This legend answered my one and only question on Stack Overflow, because I'd committed to doing this talk and I was freaking out when I couldn't get it running. And honestly, he gave me a really good answer. So some more on the GIL. It exists in the Maths Ruby interpreter, like I said, which is the C implementation of Ruby. There's different implementations of Ruby, like JRuby has Java under the hood. Rubinius has C++. So for those other implementations, you actually will see speed increase for CPU-bound tasks. I've been told, I haven't done it. The GIL actually exists for a reason, to protect Ruby from race conditions that could corrupt your data. But the good thing is that for input-output work, like writing to a database, the GIL will free up your threads, so you actually will get performance if you're writing to a database or doing something like that. So anyway, I did this, which is just, I don't know, something about sleep I don't like, but I got a tenfold increase when I did this. So I was at least happy about that, compared to synchronous, it was faster. And this is the part where you think I'm going to get out safely and not be murdered, but you're wrong. Because now I'm going to get into a Rails app. So in the long run, like I said, what I wanted to do was have this task in a content management system that the user could upload the CSV through. But it needed to go about 5 times faster than it was going in order for this to be successful. So that was kind of my goal. So I set up this arbitrary task here that just imports the dirtbags into the database. And it doesn't do any exception handling or anything, no validations, nothing, just to test how it will go. And then inside my dirtbag model, I've got 2 methods. One imports them synchronously and the other asynchronously. And so what happened when I ran this? Anybody want to guess? The whole thing blew up. So when you're using threading and you don't really know what you're doing, you'll often get, especially in the Rails app, you'll get this active record error where the connection to the database times out within 5 seconds, and then you know, you see some nodding heads. So what I've since learned is that by default, active record only allows 5 connections at a time, and I had 100 threads. So that was not going to work. Apparently you can change the default to more than 5 connections, but there was no way I was doing that on a production database, and I probably don't have permission anyway. So the second try, when I tried to run it, again, it blew up this time because I was using an SQLite database, and anyone who knows anything about that knows that it's only got 1 file that it writes to, and that file locks when you try to write to it. So multiple threads can't write to it. Then I tried it in MySQL, and it sort of worked. So this is where I'll get to talk about hardware. This was on my shitty computer at work, running Linux, and I got about a 3-fold increase when I was using a pool of 5 actors compared to synchronous. But when I took it home and ran it on this Mac, I only got 20% because this thing processes a lot faster. And you can guess that on a production server it would be even faster than this. So that's not 5 times, that's not enough. Even worse, if I ran this task more than once in the background, the entire website would be locked. You couldn't visit any page, the home page, it was locked. And what I was realizing was that, or what I come to realize is that I was actually like leaking connections to the database. So yeah, and to make it even worse, my buddy Andrew Buntine said that he got all of this running in 10 minutes using Rust the night before. And I was driving crazy at this point. So as it turns out, Ruby under the hood handles connections for you. It takes it checks out a connection and then it checks it back in. But if you're doing stuff like this, then you have to actually handle it yourself. So you can wrap. There's a bunch of ways to do it, but you can wrap it in this method, and that will check the connection back in. So in a horror movie, there's often foreshadowing about how this is going to turn out. And I'll give you some foreshadowing right now and say I'd already given up on doing this. But I had to do this talk, so I kept going. Because you can't talk about multi-threading without talking about thread safety. Like I kind of alluded to earlier, Ruby obviously has mutable state, so if you have multiple threads trying to write to an array or increment something, and they're doing it at the same time, it's going to lead you to grief. So you have to handle that in some way. This is one way that you can do it, sort of using vanilla Ruby. If you look in the initializer there, there's an instance of the mutex class. Mutex stands for mutual exclusion. This is part of the standard Ruby library. It's not cellular or anything. And then you can wrap the things that you're going to alter in this lock and synchronize them. And that will prevent them from, I think it sort of queues up the work that's coming in. Yes, and you can do something similar with celluloid. There's a bunch of ways that do it, but one is that you can publish notifications to an observer. So this is an observer class that, I'm not going to go into this because you look at the docs and I've already let you know I didn't finish it. But yeah, you can publish notifications from your actors to your observer. So if you look in the middle of this method here, it says publish done, whatevs. That's passing it to the observer. But when you log these things and deal with thread safety, it also kills your performance, which makes sense because you're taking things that are synchronous or asynchronous and forcing them to be synchronous at the end. They all just queue up. So yeah, but the time I got here, my hopes of having 5-fold increase were really dashed. So what did I actually end up doing? Basically, I take out one thread when the user's going to import the CSV. I import everything synchronously in the background, and then I email the client the results later. It doesn't matter really how long it takes because they can go and have coffee and they don't have to sit there and do anything. So what are the takeaways? Bunston's in 10 minutes in Rust. So yeah, I think Ruby's good at a lot of things. It's very expressive and powerful, but concurrence is probably not its strong point. Having said that, you can use frameworks like Celluloid, and they're not going to solve all your problems, but they definitely will help. If you're using the MRI, the Maths Ruby interpreter, and you're doing a lot of input-output work or something like that, stuff that's not CPU bound, then it might be really good for you. And obviously there's other things you can do other than import some CSV data, so there's probably lots of implementations where threads are really good. Or you can try JRuby or Rubinius, and this is actually what I want to do next, just to see and compare it. So, thanks. Questions?
Anyone recommended Forky?
Forky? Yeah, I had a few recommendations, including just use a different language. But yeah, I know there's lots of ways to improve it, so that's another thing that I'll have to try. Yeah, but I didn't give it a go. Yeah.
So I think by default the CSV libraries in Ruby are written in Ruby. There are a few gems out there that are basically just wrapped around C. Did you try any of those?
If you looked at the code, I was using Smarter CSV, which is actually a gem that helps you chunk code and stuff like that. But I didn't actually experiment with other ones. So
I think it's been a while since I've been trying because there was one written by a Japanese dude.
Yeah.
And had no documentation and it was blazingly fast.
Okay.
But I think there's one called, so it used to be fastest CSV back in the day, but now there's the fastest CSV.
Oh, okay.
It's actually the fastest.
Right.
It's just the one written by the Japanese guy and has no documentation.
Cool.
But it's worthwhile trying. I don't know the smart CSV actually. If you want to import CSV as quickly as possible,
right,
and you don't care about a bunch of features, then
yeah,
a pure C implementation will probably be faster.
Yeah, that's good thinking. I didn't show you all the code, but a lot of the time was taken up through like exception handling and stuff like that. So, but yeah, that would be cool.
There is a study case for this one.
Okay.
Ruby news website.
Yeah.
Do you understand?
I'm now.
They published like 1 month ago.
Okay. So we said have a look at Ruby News. Yeah. Cool. Time for beers?
Always time for beer.
Okay.
Any more questions?